We're going to run a rotational viscosity test, and we will use this to get your mixing and compaction temperatures to use in your lab. I'm going to go ahead and pour the sample while it's hot, and then I'll go ahead and talk about the test and the equipment. This is a 6722 asphalt binder. It has been in the oven at 140 Celsius for a couple of hours, so it's nice and runny and ready to pour. And I've stirred it up well because we stir up everything. Now I need to pour, for the spindle that we are going to use, we are going to put 8 plus or minus 1/10 of a gram into one of these aluminum sample chambers. These have also been preheated at 140 C. They were in the oven with the sample, so I'm just going to go ahead and pour that. We want the whole sample in the tube, not on the sides, not running down the top. Just want everything in there. And I need another 1/10 of a gram. Let's see if we can get this. All right. So there's 8.0. Now, I will bring it over here to the thermocell unit, and we'll drop it down in here so it can start equilibrating to its test temperature. It just slides right in like so, and then we'll twist it around until it locks. And once it locks in place, it won't be able to move when the spindle's turning, because we don't want it moving while the test is running, because that'll affect our results. This is the spindle that we're going to use. This is number 21. We have 2 spindles that we use for SuperPave testing. It's 21 and 27. This is for very stiff materials, about a PG 76 or above is when I switch to this one. But we're going to be using this one today, so I'll go ahead and place it in here. It just connects like so. And then I will lower it down. I have height guides. Whoops, and be very careful when you're lowering it, not to bend your spindle. But I have height guides on here that tell me how far down I need to be. And then I have a centering guide that gets my spindle centered in there. If we have done everything correctly and we've used the proper amount of asphalt binder, once it is connected like so, we will have 1/8 of an inch of asphalt binder above this connection right here. All right. So this is the DV2 Plus Brookfield Rotational Viscometer. There's several models out there. You may see something slightly different if you go to somebody else's lab. They all consist of the same basic working parts though. We've got a torque motor in the head with some digital controls. I've got a thermocell unit. This is what maintains my temperature. We're going to test our first sample at 135 plus or minus 1 degree Celsius. And then I've got an external temperature controller that actually keeps me within that temperature range. The rotational viscosity test is part of the SuperPave performance grading system. We run it at 135 C when we're grading our asphalt binders. It tells us that the asphalt binder is handleable, workable, pumpable at normal mixing temperatures. And have the best binder in the world, meet any PG grade you want it to. If it's so stiff and nasty and unworkable at normal temperatures, then nobody's going to want to buy it. So we're allowed a maximum of 3 Pascal seconds at 135 Celsius. And again, that's just to ensure that we can actually work with this material. For the test, once I've got everything together, I'm going to let it get back up to temperature. I've got my digital readout right now set to % torque. My speed is 20 RPM. That is what's required for SuperPave. We rarely vary off of that. And I can hit motor on. And I'm going to watch this % torque. I want to make sure it doesn't go above 98%. If it does, I need to turn the machine back off because I'm going to break my torque motor. Usually, if that happens, I can just wait a couple minutes and try it again, and it'll be warm enough to run. If I've got a sample I just can't get below 98%, then that is when I would pour a new sample and switch to this little guy. But we went up to 32 or so, and now it's coming back down. So this is good, and I can go ahead and hit select display. And I can read my viscosity and centipoise right off the digital readout here. The other readings here, I've got spindle number, that is 21, this is 27. The spindle number tells the machine basically what spindle it has, what's its size, what's its weight, diameter, whatever it needs to know to do the viscosity calculation. So this is spinning at 20 RPM, and we right now have to leave it to equilibrate for 10 minutes. This has been spinning for about 10 minutes now. We are required a minimum 10-minute equilibrium time. So I'm going to take my first reading. It's going to be 570 centipoise. Now we need to report in Pascal seconds. We just divide by 1,000. So I'm going to write down my first reading as 0.570 Pascal seconds. And this is at 135 Celsius. I'm also going to check my percent torque just to make sure that we are still within tolerance. And we are at 22.8. We are allowed to be between 10 and 98% torque. Well, I've already talked about the 98%. Below 10%, then the sample is so liquid at that temperature that we're not getting a lot of resistance to the spindle turning, and we are just getting noise, basically. So we are valid on our torque, 22.6. And I'll go back to slate display. Our test results, we write down 3 readings. We wait 1 minute between each of them. This lets us know that we are fully equilibrated. If the results are still going up or down or bouncing all around, then we kind of need to wait a few more minutes and figure out what's going on, see if we can get it to stabilize. So it's been a minute, and we'll take our second reading, 0.570, so far so good. And again, this is Pascal seconds. And we'll wait 1 more minute and take our third one. And 0.570. So I'm going to write down for my viscosity at 135C, it's 0.570. For mixing and compaction temperatures, we need to get a range of results. So I'm going to do 135C because I have to do that anyway for superpave grading, so I might as well kill 2 birds with 1 stone. My second temperature, I'm going to use 165C because I know it works for this binder. And so I'm going to go over here and change this. And now we'll wait and let that equilibrate. Leave the sample. We can run the same sample, still 20 RPM. I don't have to turn it off. It can just sit here and spin for the equilibration time. But this will take a couple of minutes. These are very small samples. This thermocell unit is very good. It heats up pretty quickly. We have equilibrated at 165 Celsius. We're going to take our first reading. It is 165 centipoise, so that is 0.165 Pascal seconds. And same as before, we will wait a minute between each reading. 0.165 for the second one. And we'll wait 1 more minute and take our final reading. And 0.165 for an average of 0.165. Both of these are well below our 3 Pascal second maximum that we're allowed in superpave. So this binder should have absolutely no problems for superpave grading. If you do have a binder that fails that 3 Pascal second maximum, go look at the chart, the AASHTO M320 chart. Read the fine print. There is actually a note in there that says if you have an asphalt binder that is greater than 3 Pascal seconds at 135 Celsius, and you as the supplier of that binder are willing to certify that it is pumpable, then you can possibly get that requirement waived. So it's not a set in stone requirement. There is an out if you fail it, because we do have binders that we know based on the way they're made, they are very stiff, but they're still very workable. So that's in there for those binders. I'm just going to turn this off and we are done.